Good morning, everybody. If you're watching this video, that means you just recently finished the lab and any follow-up questions. So we are ready to move on and do our brief lecture video of the day on polyatomic ions. Now, in your lab, you're already exposed to a few polyatomic ions. You can see one right here and one right here. We'll see if you actually figured them out correctly when accomplishing your lab. What a polyatomic ion is it's an ion, meaning it has a charge, because that's what defines an ion, a charged particle. It's an ion that is composed of multiple elements, or like polyatomic, multiple atoms, atoms of multiple elements. So like ammonium right here, this example we're looking at on the screen, has nitrogen and hydrogen. You combine them in the form NH4, and they have a positive charge. Or we look at carbonate, CO3, 2-. So it comes with carbon, 3 oxygens, and a charge of 2-. Now, polyatomic ions can never, ever be separated. Meaning, if you have hydroxide, the O and the H always have to stay together. And they're always going to come with a -1 charge. These are just like ions. Just like chlorine has a 1- charge, nitrite has a 1- charge. Just like sulfur has a 2- charge, sulfite has a 2- charge. So these have to stay together, this SO3, and it's always going to come with a 2- charge. Now these are the 10 polyatomic ions that we need to know, or that we're going to use throughout the rest of this class. So I would pause this for a minute and make sure you write down clearly the 10 different ions we are going to use in this class. And I have them separated for you. I have the positive ions, positive polyatomic ions, the ones with a 1- charge, the ones with a 2- charge, and the ones with a 3- charge. So go ahead and write those down now. Okay, hopefully you paused it, took down those polyatomic ions. I'm going to show you a few examples so you can see that using polyatomic ions is just like using regular ions when solving for a problem. Everybody remember the crisscross method? It still works. That's the best part, is we don't have to change anything. So one example we could do would be calcium carbonate. So Ca is calcium, right? You still do the same process. You write down the symbol first. So we have calcium, and we see on our periodic table it has a 2+ charge. And then like carbonate, what in the world is carbonate? Oh, well look at that. Mr. Wilson gave me carbonate right here. Let me go find it. Oh, CO3, CO3. And what's its charge? That's a 3, I promise. CO3, 2-. So I put my 2- right here. Okay, now how in the world do I solve this and put this together? Well, crisscross. The same exact thing you did for regular ions. So you take this 2 charge and you would put it down here. Take this 2 charge and you would put it down here. They cancel each other out because they're both 2s. So you'd have Ca, CO3. You wouldn't have to add any extra exponents because these are both 2s, so I actually don't have to write them because they're the same number, because they equal each other. So it would just be Ca, CO3, and that would be your final answer for calcium carbonate. Now, let's do an example where you would have to write the numbers at the bottom. Okay, so that was calcium carbonate. Look at magnesium nitrate. So the first thing you do is write down the symbols with the charges. So magnesium we see has a 2+ charge. And we see nitrate right here. Mr. Wilson is so awesome again giving me nitrate. So I see nitrate right here is NO3, 1-. Okay. So we have Mg2+, NO3, 1-. And we're putting these together to form an ionic compound. Remember, this polyatomic ion always has to stay together. You can basically picture this as one element right here. This is all one thing, and this is one thing. So how do we solve? Well, we have down our charges and our elements, so now we crisscross. We take our 2, we're going to put it down here with the NO3. We take our 1-, and we're going to put it down here with the magnesium. And that's it. We just got to make sure you put everything in the right place. So I have Mg magnesium, and remember I moved a 1 down here, so I don't need to write that. I don't have to write the 1. and then I'm going to use parentheses and put NO3 NO3, because remember, this has to stay the same all the time, NO3, and then 2, because I moved this 2 down here. Now, one thing that has confused people in the past is that you think, oh, I moved the 2 down here, and I get rid of this 3, and I put a 2. No. Whatever it is right here, whatever you wrote down for your polyatomic ions, NO2 minus, NO3 minus, those stay the same. NO3 has to stay the same. But because we moved a 2 down here, that means we needed 2 NO3s, 2 nitrates. That is why I put it in parentheses, just like this. And it works perfect. So you have NO3, 2. That means we have 2 NO3s. Why does that work? Because magnesium has a 2 positive charge, nitrate has a 1 minus charge, so we need 2 nitrates to equal 1 magnesium. So we have magnesium nitrate right there. Hopefully everybody sees why we kept this 3 and why we put this in parentheses. So we could show we needed 2 of everything. You're going to use parentheses a lot with polyatomic ions, so just use them liberally, which means use them all the time. Okay, one more example. Barium has a 2 plus charge, so we're doing barium phosphate. So I look at barium, I see barium has a 2 plus charge, and then I look at phosphate. I see that it's PO4, 3 minus. PO4, 3 minus. Okay, so those are our 2 charges. This is our element number 1, and this is our polyatomic ion over here. We want to bring these together in barium phosphate. My first step I already accomplished because I wrote down the element with the charge. My second step, I crisscross. So I know I'm going to bring the 2 over here to phosphate, and I'm going to bring the 3 over here to barium. Now let's write this carefully. I have barium, B, A. And what do I put next to barium? I brought a 3 down here, so I'm going to put 3. Now I'm going to write phosphate, PO4, because it has to stay the same. It's PO4 right here. Now we moved a 2 down here. Am I going to write the 2 right next to the 4? No, because then it's going to look like 42, and that's not going to make any sense. In order to prevent that, I put in parentheses. I put in parentheses, and then I put my 2 just outside the parentheses. So anytime you're using these polyatomic ions, just plan on using parentheses. The reason we do is because then it shows that we need 2 of the entire polyatomic ion right there. So this works perfect. So we have Ba3, PO4, 2. So you can see that as barium phosphate. Now, when you're naming these, it's really straightforward. All you do, you don't end in "-ide" for polyatomic ions. If you see something like this, it's just barium phosphate. So it's just the name of the element and the name of the polyatomic ion. Pretty straightforward, right? So if you look at this paper that you have, on one side, it has where you need to write the names. On the other side, it has where you need to write the formulas. This is really just for practice. This is really similar to what we did yesterday, but it's because we need a lot of practice and a lot of repetition doing this. So if you see, for example, like if you look at like BaNO3, you just look up what Ba is, it's barium, and then find NO3 on here, it's nitrate, so it's just barium nitrate. You don't have to change anything, so it's really nice. As long as you can find what polyatomic ion it is, what element it is, you're good. Okay, as soon as you finish this video, if you're with your partner or with your group, you've already finished the lab, move on to this because we're going to practice using this because we've got to practice our polyatomic ion usage so that we can do a little CSI activity tomorrow. All right, well, until next time, which I'm sure you just can't wait. This is like better than seeing a movie on the weekend watching this. Should get nominated for like an Oscar or something.